Hi everyone, in this video we will see how an AM wave is generated. So there are two ways to generate an AM signal. First one is your switching modulation and second method is the square law modulation. Today we will see the AM wave generation using a switching modulation. So switching modulation. In switching modulation we use diode. As we know, the diode acts as a switch, so that is the reason we are using diode in switching modulation. Let us see the circuit diagram. In the circuit diagram, at the input side, that is Vi of t, we will be having a carrier wave as well as a message signal. Why are we having a carrier wave? Because our main aim is to transmit this message signal to the transmitter side without any noise. So that's why the message signal is superimposed on a carrier signal to transmit over a longer distance without any interference of the noise. That is why we will be having a carrier signal at the input side. So as I said, the diode is a main component in the switching modulation because the diode acts as a switch. So when the carrier signal and the message signal is transmitted over a band pass filter, we would be having our output. So here I wrote C of t is equals to carrier wave and M of t is your message signal, where the carrier wave is your highest frequency signal. Why are we using the carrier wave? To transmit our message signal to the longer distance without any interference of the noise. Okay, now this is your circuit diagram. And so whenever we are sending a carrier signal which is positive, that is the half cycle, the positive half cycle of a carrier signal is pass it through the diode acts as a switch, right? So when the positive half cycle is transmitted over the diode, it becomes short circuited and it acts as a forward biased. So when it is short circuited, we would be not having any of these, no filter, nothing. So the Vi of t is equal to V naught of t. So input is equal to output. So the equation would become Vi of t equal to V naught of t. And in the second case is that reverse biased. Then a negative half cycle of a carrier wave is passed through the diode, it becomes reverse biased. So it becomes an open circuit and then V naught of t equal to 0. So there are two cases in this. One is positive half cycle and another one is negative half cycle. In positive half cycle, Vi of t equal to V naught of t. In the negative half cycle, that is case 2, V naught of t equal to 0. So there are two equations from case 1 and case 2. So V naught of t equal to Vi of t, that is equation 1, when C of t is greater than 0, that is positive half cycle. V naught of t equal to 0 when C of t is less than 0, that is your negative half cycle. So we will be getting two equations from the positive half cycle and the negative half cycle. And now, as I told you, the Vi of t has C of t plus M of t. C of t is your carrier wave, M of t is your message signal. So Vi of t would become M of t plus C of t, where C of t is equals to, so M of t plus C of t, where C of t equals to AC cos 2 pi fct. So AC cos 2 pi fct. So I'm substituting C of t here. So my Vi of t would become M of t plus AC cos 2 pi fct. Now I have found Vi of t and now we need to find V naught of t. So V naught of t could be represented as M of t plus AC cos 2 pi fct into the Gp of t. So here Gp of t is your gate periodic function. Why are we using Gp of t in the output side? Why? Because I told you diode acts as a switch, and there are two cases which we are considering, that is positive half cycle and negative half cycle. So in the positive half cycle, the diode is in the on condition. In the negative half cycle, the diode is in the off condition. So to calculate the both of those conditions, we would be using a gate periodic function which keeps in track of both those things. Okay, so the gate periodic function, for example, I am taking the wave from T0 by 4 to T0 by 4, minus T0 by 4 to T0 by 4. So this is my wave of a gate periodic function. Okay. So the gate periodic signal can be represented in the Fourier series form, that is Gp of t equal to 1 by 2 plus 2 by pi sigma n equals to 1 to infinity minus 1 n to the power n minus 1 by 2n minus 1 cos 2 pi fct into 2n minus 1. So this is the representation of a gate periodic function. This is not something which is derived, you have to remember this. Okay, and now this is your equation number 4. So we are going to substitute the equation number 4 in equation number 3. What is our equation number 3? Our equation number 3 is the V0 of t, that is the output. The output is nothing but m of t plus ac cos 2 pi fct into the gate periodic function. We have found the gate periodic function in Fourier series form. So we're going to substitute the gate periodic function and multiply that function with this. So after substituting, this would be my equation. So this is my Vi of t. Vi of t is nothing but message signal plus carrier signal with the Gp of t, that is the gate periodic function. And now I'm going to multiply each of the term with the gate periodic function to achieve the equation number 6. After multiplying each of the term, I would be getting the equation number 6. So in the equation number 6, I am not considering the message signal, that is divided by 2, and the carrier signal, that is the square. So I'm just considering the middle terms. So after simplifying the middle terms, that is I'm taking AC by 2 common, so I will be remaining with this equation. So here this is my modulus factor. So this is the required AM signal. The equation number 7 is the required AM signal with the mod factor, that is 4 by pi AC. So this is my mod factor. So now that we have achieved equation number 7, we are going to transmit this message through the band pass filter. Why are we doing that? Because our AM wave can have a message signal with the noise, right? So during the transmission, there is a chance of noise which is entering through it. So at the transmitter side, we would be having a band pass filter which is useful for removing the unwanted noise which is present in our message signal. So this is the generation of AM modulation wave, AM wave. So in our next video, we will see what is demodulation and how the AM wave is demodulated and what are the techniques used in it. Thank you.